So the question is basically combination. So you have to, like, in how many ways you can do this. It's talking about combinatorics. Now the question says you have 5 different awards, like you have 5 different candies. You want to give it to 3 kids, but you have a restriction that every kid has to at least receive 1 candy. So basically there are 3 spots, kid number 1, 2, 3, and then you have 5 objects you want to distribute it in these 3 different spots such that at least each spot has 1 gift. Now, when it comes to those restrictions, sometimes, like, there are different things you can do. Sometimes you can just remove the restriction, say, okay, first I assume in how many ways I can do it regardless of if a kid receives 1 candy or less than 1 candy. And then at the end say, okay, this was the total number of ways I could do this. Now I'll subtract some part. Or you can break it down into some simpler parts and then add them. Both of them are good strategies and it depends on the problem. Right now what I will do is I'll break it down into different cases, find the solution of those different cases, and then add them. So when we say we have 3 kids and each of them must receive 1 candy and you have 5 candies, there are only 2 options. One of them gets 3 candy and then the other 2 get 1, or 2 of them have 2 candies and then the last one has 1 candy. Now be careful because the question says in how many different ways we can do that. The arrangement is important. So the first kid could get 3 candies. Maybe the second kid is the one that gets 3 candies and the first one and the third one get 1 candy. Or maybe the third kid receives 3 candies and the first 2 kids get 1 candy. So we solve it for this case and then at the end we multiply it by 3 because the one that gets 3 candies could be number A, could be number B, could be number C. So we're going to solve it and then at the end multiply by 3. Now, what is this? I have 5 candies. Out of those 5 candies, I want to give 3 candies to the first kid. So it's basically the problem of choosing. In how many ways you can choose 3 candies to get to a kid. So we have 5 candies. We want to choose 3 of them. So that gives us 5 out of 3, excuse me, not out of 3, 5 choosing 3 different ways for the first kid. Now you only have 2 candies left. In how many ways you can give those 2 candies to kid number 2 and kid number 3. Both of them have to get a candy. So 2 candies, 2 kids, 2 ways. You can give, as an example, if there is a red candy and blue candy, you can say red blue or blue red. It's just 2. So you just multiply it by 2 and what you're going to get is combinations is 5 factorial, 3 factorial, 2, and 5 factorial. I'll just cancel these 2 because they're the same. So it's 5 factorial divided by 3 factorial, which is 20. But this is not completely correct because what this means is in 20 different ways, the first kid can get 3 candies and the second and third kid can get only 1 candies. Now, what if the second kid, the middle one, is the one that gets 3 candies? So this is what I said. At the end, you have to multiply by 3. So when I multiply by 3, I get 60 different ways. So the combination of 3, 1, 1 gives us 60 different ways. We're going to do the same thing with this one. Now, I have 5 candies. In how many ways I can get and choose 2 candies to get it to the first kid? So it's 5 choose 2. Now be careful. You had 5 candies. You gave 2 candies to the first kid. So now you have 3 candies. Out of those 3 candies, you want to select again or choose 2 candies and give it to the middle one. So that's it. And then the last one just doesn't have any option because you have given 4 candies to the first 2 kids. It's just 1, which is this. Again, at the end, you have to multiply this by something because this is only one combination of 2, 2, 1. Maybe the first one is the one who gets 1 candy. We're going to talk about it. And that's 5 factorial, 2 factorial, 3 factorial times 3 factorial, 2 factorial, 1 factorial. And that's 10, that's 3, which is 30. Now again, in how many ways? Let's not think of these 2. Let's just think of this. The one who gets 1 candy could be the last one, the middle one, or the first one. So again, at the end, we have to multiply this by 3, which you're going to get 90. That gives us 90 ways and 60 ways, in total 150 ways.